Good evening. In this short video, I plan to talk about the A and B modules, as well as give some more context for Synergetics. Uh, I'm going to differentiate into two levels of Synergetics. This is being recorded for a playlist on YouTube I'm calling Synergetics 101. And what may be missing, what you may have felt missing if you've watched most of those videos, is I haven't really gotten into the geodesic dome all that much. And yet that's what people stereotypically associate Fuller with, because when he really came to fame, people started to know who he was. It was in connection with books like this, Geodesic Math and How to Use It. This is by Hugh Kenner. He's a literature professor, an expert in James Joyce in particular. He also, though, I would say, is a polymath. And not only did he write this book, which you could call a math book, but he also wrote Bucky, which is a biography of Buckminster Fuller. He also wrote for MITE magazine, McGraw-Hill. Geodesics by Edward Popko. Now, Popko has another more recent book out called Divided Spheres, which gets a lot more into the theory of building geodesic structures, different ways of doing that. I talk about the ray dome and some of that in Synergetics 101, but there's more ahead. I'm going to have more artifacts to show. From Sam Lanahan, from other sources. So stay tuned. Now tonight I just want to talk some basic module stuff. The MITE we've been talking about, 24 of them will assemble our cube of volume 3. And what I want to do is dissect the MITE. We're not going to stop at the MITE, although it is the first tetrahedron that fills space without left to right-handedness. So there's the MITE. You can dissect it into what are called A and B modules. Let's take a look at those. These are the A modules. Start with your regular tetrahedron, divide it up into 4 quadrants, and then slice along these internal lines from opposite vertices to mid edges, and you get 6 slices per quadrant. So that's 24 slices in all, 12 left-handed, 12 right-handed. They're mirror images of each other. You could call them positive and negative, left and right, inside out of each other. You can fold them both from the same plane net. You can just fold towards you or away from you to get the left and the right A modules. Now, the B modules are very similar. We start with an octahedron, the complementary shape in the isotropic vector matrix, except I'm not seeing it here. Let me quickly go find it in this figure index for Synergetics. Here we go. The B modules do the same thing. Take one of the 8 octants of the regular octahedron of volume 4 and pull that out, and you get a section, 8 of these. However, each of those sections already has A modules in it. The shallower tetrahedron is the quadrant from the tetrahedron before. Same shape. So in subtracting the A modules from this larger region, we are left with the B modules. Now that's a little bit different treatment than you'll find in this excellent book by Robert Williams called The Geometrical Foundation of Natural Structure. A lot of us who are students of Synergetics will also have other books in our collection, such as this one. However, his treatment of the A and B is a little bit different. I think I was alluding to that earlier in another video as what got Fuller to publish, really, because he realized that if he didn't tell it the way he wanted to, It was going to disseminate through his students in what he would maybe think of as a more garbled form. Robert Williams got access to Synergetics before it was published. He talks about how and where somewhere in the book. So A and B modules, how do they make the MITE? This picture shows how we can take two A modules, the left and the right, or the positive and the negative, and then face bond that left-right with either a positive B or a negative B. So depending on which way we go, we'll get a MITE. Either way we'll get a MITE, a left-handed or a right-handed B. You always use both A's and then either a left or right B. But once you're done, you can't tell one MITE from another in terms of handedness. Whether this has a left or a right B inside, there's not any way to tell from the outward angles. So these mites become our space fillers. The Somerville tetrahedron is one that fills space without needing left or right and no complementary shape, just all by itself fills space. The MITE does that, as do the things that the MITE will make that are also tetrahedra. If you recall in other videos, we call these sites, and one of those would be the right. The right is another space-filling tetrahedron, and if you put a point at the center of this, kind of like we do when we're creating the A modules, the quadrants that you get out of a right are also space fillers. And I think that covers the tetrahedra that Somerville found as well. The MITE, two ways of making sites, and then the quarter right. So that would be, you can look up if there is more. Now if you loosen the rules and say they don't actually have to fill space by face bonding, then you can get more. You can get infinite at that point, infinite number. A mathematician named Goldberg comes up in another context, was really interested in that more general answer to the question. So let's stop here with the A and B modules. You'll see how we move on to the T and the E modules with the rhombic tricontahedron and other videos, and also the S module, which is developed from the octahedron of volume 4, and it's inscribed icosahedron. The S, T, A, and B, S, T, E, A, and B are pretty much all we need to get going in Synergetics. That's enough to, now we're going to learn how to phi scale the S, E, and T. In other words, this is something David Koski has been pioneering quite a bit, how you can create other volumes either just numerically or through actual assembly by using phi scaled T's and E's and S's together. I'm going to save that as well as the more spherical geodesic aspects of Synergetics for a different playlist, for what we'll call Synergetics 200 or something like that. So please watch the rest of these in Synergetics 101 if you want a good beginning, a good starting point, and then stay tuned for some really interesting videos in the future.